velocity to a particular frame of reference, and everything is always at rest to at least to one frame of reference. In mental ease, the agonist exerts a greater or lesser force on the antagonist exerts a greater or lesser force onto the agonist. So, for example, the ridge prevented the log sliding further down the hill. The log here is the agonist. It has a tendency towards moving. It wants to continue sliding further down the hill. The antagonist is the ridge. The ridge is going to act against the log, and the ridge wins. The ridge exerts a greater force on the log, and then the log comes to rest. The ridge prevents the log from sliding further down the hill. In physics, we know that when two objects are touching each other and they're at rest, that they're exerting equal and opposite forces upon each other. So it's quite different. And in physics, there's no obvious role for causing, blocking, preventing, permitting, and helping, and preventing. And these concepts form naturally out of the 2 by 2 by 2 array of binary propositions which catch all the causal propositions of all the languages in the world. So we can use this to help understand a moral dilemma. This is Philippa Foot's trolley problem from 1978, and the idea is this trolley here is out of control, and it's either going to kill 5 workers or 1 worker, depending on which set of tracks you set the trolley onto. So in 2007, 90% of 150,000 web respondents said that they'd switch the trolley tracks so that the trolley kills the 1 worker. And that's as pretty close as unanimous as you get in a survey, because about 10% of people will just randomly respond to anything. So this is an alternative version of the trolley problem. Here we have a fat man on the bridge, and the antagonist has to throw the fat man off the bridge onto the tracks, and they'll stop the trolley from killing the 5 people. Right? So the maths is the same. It's 5 lives for 1. However, no one seems to want to throw the fat man off the bridge. And if you give people this problem and you put them in an MRI scanner, what you find is that emotional centers of the brain become active, as well as conflict resolution centers in the brain. And we can understand this moral dilemma as an interaction between 2 different innate processing systems in the mind. One processing system is making causal constructions, and another is working with sentient calculus. It's trying to attribute personality traits to innate essence, which is in the antagonist. So in the original version of the trolley problem, the trolley has the innate tendency towards being the killer, and the antagonist is just affecting the trolley. But the trolley was always the killer. And in the second version, the antagonist becomes the killer of the innocent fat man. And obviously we have problems with that. If the antagonist throws the fat man off the bridge, then we're going to associate particular personality qualities with the antagonist, and we're going to use those to try and predict the antagonist's behavior in the future. Right? So if you can convince yourself that the trolley always had the tendency towards killing, and it wasn't the antagonist which had the tendency towards killing, then maybe you'd throw the fat man onto the tracks. Okay, so there's one aspect of this trolley problem which hasn't been discussed, which is extremely important, which is that there's qualia associated with the trolley problem. Everything that we're conscious of about the trolley problem is the qualia of the trolley problem. So we know that this is a moral dilemma. And the quality of a dilemma is that there's no solution to it. So if you answer this way, this information processing system will complain, and if you answer this way, this information processing system will complain. So we can talk about it forever, and to the end of the earth. So our legal system in religion is based on the notion of free will, and this is where free will comes from. We can imagine ourselves on the bridge. We have to decide whether we're going to kill the fat man or not. We have the qualia that's associated with the moral dilemma, and then we make a decision based on our beliefs. And then with the legal system, we'll get tried by a jury of our peers, and the peers will decide whether or not we did the right thing. Now, in philosophy, a zombie is an identical physical creation to a human being, except for it has no qualia. And so if you created a zombie, the zombie wouldn't have the qualia of the trolley problem, so therefore probably it's arguable, or the idea is that you can argue that it doesn't have free will. So a zombie can never know that this is a moral dilemma. Now, Marvin Minsky makes a very clever argument against the zombie, that you can't have a zombie because the zombie presupposes that you can actually create an identical replication of a human being without qualia. And that's kind of like saying that qualia is not an important part of what human beings are. Now, obviously, that's wrong at a certain level because we all experience qualia. So really, if a zombie can't deduce cogito ergo sum, if a zombie can't do that and it doesn't have qualia, so it can't, then how can it be identical to a human being? So this brings us to what are qualia? Where do qualia sit in the information processing pipeline of the human brain? Now, there's really a lot that's written on qualia. Qualia is a central topic to the philosophy of mind. And I found this excellent article by Ramachandran and Hurston from 1997 called The Three Laws of Qualia. And they present a view of qualia which is consistent with the information processing theory of the mind, and therefore it's useful for artificial intelligence researchers. The first law is that the input is irrevocable. So the sensory input is full of uncertainties. The heuristics we apply to the sensory input is full of uncertainties. The storyline we create is full of uncertainties. And it's presented as a real, coherent, smoothed over, perfect reality in the present moment. So for example, we have this bistable picture. It's either a rabbit or a duck. It's never both at the same time. So in any instant of time, you see a rabbit or a duck, and you can switch between the two as fast as you can. But they can never be the same at the same time. They can never be both at the same time, so the input's irrevocable. So the qualia is just generated one way or the other. The second law of qualia is that there's choice of output. So this is where the notion of free will comes from. So there's no qualia associated with the operation of the primary visual cortex back here, and there's no qualia that's associated with the reflex arc. They're just information processing systems that happen. And it's important to appreciate when there is qualia and when there isn't qualia associated with information processing systems. And Ramachandran and Hurston suggest that there will never be qualia associated unless there's some choice of output that's involved. And finally, qualia are constructed in working memory. So working memory is, in psychology, it's the equivalent of the processing cache, or the cache memory of the human brain. So qualia are constructed in this volatile memory where it's processed. And Ramachandran and Hurston suggest that an executive process, qualia is the input to the executive process. Now, the executive process is an obvious idea, but it's still a very good idea in cognitive psychology. And it comes from the 1965 Michaux. And the executive process initiates controlled processes, and it also engages in